Okay, so in this video, I just want to speak about vectors. Sorry, it's not meant to be a red pen, it's meant to be a black pen. So in this video, I just want to speak about vectors and scalars. Okay? The reason I want to speak about vectors and scalars in this video is because it's just going to help you understand momentum and forces even more clearly. And if you watch this video and then go back to the previous two videos that I posted, you might understand what I'm talking about in the previous two videos even better, or just come to a better conclusion. So for example, what is a scalar? A scalar is anything with magnitude. And a vector is anything with magnitude and direction. So a scalar is anything with magnitude, a vector is anything with magnitude and direction. What does this mean? For example, you can take an object such as a ball, a red ball, and one of its properties is its mass. Now the mass of this object is that a scalar or a vector? Well, I can say this ball is 5 kg, and this is all the information you need to understand that what this ball's essential weight is. You understand that its mass is 5 kg. You need no other information. So mass is essentially a scalar. Now, if I draw another ball like this, and then red ball again, and then I say that this ball's got a momentum of 100 Newton meters. Now it's got 100 Newton meters of momentum, okay, so 100, but in what direction? Is it moving in this direction, in this direction, in this direction, in this direction? In what direction? You just don't know. So in terms of that, when I say a ball's got 100 Newton meters of momentum, you'd ask me, in what direction is that ball moving? Because you don't know. So momentum is a vector. Is a vector. Similarly, if I said that you've got a ball like this, right, and it's a red ball again, and let's say it's experiencing a force, I say that this ball is experiencing a force of 10 newtons. Then the question is, in what direction? Is it experiencing 10 newtons of force in this direction, in this direction, in this direction, in this direction, in this direction? In what direction is it facing that force? Therefore, this is also a vector. Now, something about vectors is, because they need a direction to be described as well, if I gave you, if I say that, um, if I say moving towards the right hand side, moving toward the right hand side is positive, okay? Let's just say moving toward the right hand side is positive. And I say that this ball has got a momentum. I say this ball has got a momentum of 5 newtons of 5 newtons, okay? How would you draw on this momentum? Essentially what you're saying is it's got a momentum of 5. Oh, sorry, no, that's the wrong statement. It's not meant to be momentum, it's meant to be force. This ball has got a force. Has got a force of 5 newtons acting on it. So when I ask you, when I say, how would you draw this 5 Newton force on this ball? You'll tell me that you draw an arrow pointing towards the right hand side like this, 5 Newtons of force in the positive direction. Now, if I say, if with the same ball, but I say this time that it's got a force of negative 5 Newtons, if this direction is positive, then the opposite direction will be negative. So this time you draw the force like this, 5 newtons. You do not put a minus sign with it because you already changed the direction. Okay? once you've changed the direction, of the arrow, you don't have to put the negative sign in it. Or you could put it like this and have the arrow pointing forwards, but you'd have to put -5 newtons. These two, both of these diagrams are correct, but rather than putting -5 newtons like this, people like to visualize it like this. So -5 newtons, you just have all the forces positive, and then the arrows describe where the force is acting. Okay. I hope that makes sense. So when I say this ball has got a force of -5 newtons acting on it, I can draw the force. Like this, or I could draw it like this, and they're both correct. Okay. Just take a look at that diagram, and I hope you understand it. Next, let's say for example, a ball has a momentum. A ball has a momentum of 5 Newton meters in the positive x direction. Okay, so the positive x direction is in that direction. Okay, so this ball has a momentum of 5 Newton meters in the positive x direction. So I can draw now like this, 5 Newton meters. This not a force. A force is a change in momentum per second. Okay, this arrow is not showing a force, rather this arrow is just showing the momentum of the ball. The ball has got a momentum of 5 newtons per second. This ball is traveling at a constant speed, okay, at a constant velocity. Now I say there is a force on the ball of there is a force on the ball that is changing there's a force on the ball that is reducing the momentum of the ball by 2.5 newton meters per second. Then it just asks you to then draw on this force in color red. Okay, in color red. Okay, so essentially what it's saying is there's a force on the ball that is reducing the momentum of the ball by 2.5 Newton meters. That's not millimeters, that's Newton meters. That's an N right there, per second. Draw on this force in the color red. This is momentum. Okay, this is not a force. Arrows can mean velocity, right? Something like this can mean acceleration. An arrow can also mean a force. And this arrow in this case, because it's a vector because momentum is also a vector quantity, I'm just showing the vector quantity as an arrow. Okay, but this is momentum. It's not. I'm not saying that this is a force. Now this is saying that there's a force on the ball that is reducing the momentum of the ball by 2.5 Newton meters per second. Draw on this force in the color red. So if it's reducing this momentum, which means that this arrow is getting smaller and smaller and smaller, that basically means, okay, so it's reducing, which means that the force is negative. Okay, the positive x direction is in this direction. If the force is negative, then the force is going to be in the negative direction like this, and it's going to be 2.5 newtons like that. Okay, so this is a force. I hope you understand what I've done here. So this is the same ball, I've just drawn the force on it. Okay, I hope this has cleared up vectors and scalars and what I did in my previous videos. Yeah, that's it. If you have any questions whatsoever, tell me in the YouTube comments.